Okay, let me just expound on this cheating thing I'm letting you guys do. So rather than plugging them into the formulas, I'm going to be okay with if you just do this. You find that you do the reflection, you say, okay, this point is negative 1, 0, negative 1, 0. This point here is 0, 1, 0, 1. This point here is negative 2, 1. So then you don't have to plug them into the formula. That's okay.
You can always use the formula to like double check.
Yeah, but I'm not gonna force you guys to do that. It'll be okay. It'll be all right. Won't be the end of the world. Okay. So we'll go over number 3. Alright, so again, I'm going to write f of x, but every time I see an x, I'm going to put, anytime you're substituting in for x, you're just going to rewrite the same function, only every time you see an x, you're going to put a giant parentheses. So that's my substitution for, my setup for substituting for x. Now what am I going to substitute in for x? Negative x. So I'm going to write in, everywhere I see the parentheses, I'm going to write in, I substitute in negative x, so everywhere here I'm going to write in negative x into there. Okay, good. Now, is there anything acting on this parentheses? Yeah, it's being cubed. So if I take a negative times a negative times a negative, what do I get? A negative. Okay, and then I take x to the third power, what do I get? X to the third power. Everybody on board? So that's the new function. So there's my function. G of x equals negative x to the third power. Now I'm going to graph it and reflect it across the y-axis. So here is this spot. This spot here is, so I'm just going to kind of pick five spots here. And I'm going to reflect each one of them across the y-axis, right? We're going across the y-axis at this point. So here on 2 to the right, I'm going to take the same thing, I'm going to go 2 to the left. This one here, I'm 1 to the right, so I'm saying I'm going to go 1 to the left. Here I'm right on the line, so I'm going to stay on the line. Here I'm 1 to the left, I'm going to go 1 to the right. Here I'm 2 to the right, I'm going to go 2 to the left, I'm going to go 2 to the right. And then I'm going to draw in my little line here to connect it. Okay, so far? Alright, so now I need to just make myself a little table here. X, Y, and pick some numbers from here. Let's see, I've got, this one is negative 2, 8. This one is negative 1, 1. And then this one here, I'll go with this one over here, so that's positive 1, negative 1. And that's good enough. Okay, so you guys kind of following how to do these ones?
But our points don't have to match your numbers because we just randomly picked points on the graph to do
Right.
it, right? Okay.
Right, but you should have been that one or 0, 0, or it might have been this one, 2, negative 8. That would have been another one. Okay, oh, yep, so I think we should be done with this part. So I'm going to move on. It's been a while. I'm going to move on and we're going to go over this one. So here, again, f giant parentheses equals 1 over, I see an x, I'm going to put giant parentheses. What am I going to put in there? I'm substituting in negative x for x. Is there anything acting on this parentheses? Anything being multiplied in front or anything being raised to a power? No. Nope, so I can take it away. So this becomes g of x equals 1 over x, and then negative x. But here's the thing. When you have a negative x, you can leave it on the bottom, or you can put it in front, or you can put it on top, any one of those. Typically we stick it in front or on top. So I'm going to put it in front. That way you guys feel better about it. Good? Remember, this is the same thing as negative in the front. It's also the same thing as if I put the negative on the top. They're all the same. Whether you stick it on the bottom, in the middle, in the front, or on the top. All the same.
With the g of x, isn't it g of negative x?
No, f of negative x. F of negative x is g. So if I put in negative x into the function f, I'll get g. This is a different function, right? That one's 1 over x. This is 1 over negative x. So that's why I have to call it something else. Okay, so the first one, I'm just putting in negative x in for x, into f.
Okay, yeah.
So this is f of negative x. F of negative x is g.
Okay, but then I just don't understand why you're changing the thing now.
Because this is not the same. This is not the same as f of x. F of x would be this. That's f of x. This is g of x. G of x is negative 1 over x. F of x is 1 over x. So this is f of x. If I put a negative in front of it, that's a different function. It's g of x. Here, let me show you on the drawing. See this drawing here? Look at the drawing, the graph. That's f of x. G of x is this. That's not the same.
No.
So this is g of x. This is f of x. If I went to Desmos and put in negative 1 over x, that's what it would give me, this stuff in red. All right, let's pick some points. Sorry. X and y. I'll put x is 1. When x is 1, y is negative 1. When x is negative 1, y is 1. When x is 2, I guess you could say y is, negative 1/2, negative 0.5.
Yeah.
Yeah, that works. Oh, we're over time. All right, so, so this one I'm just going to show you guys. So here, g of x would be negative x squared plus 1. But if you take negative x and you square it, you're just going to get the same thing, x squared plus 1. And if you reflect this point here goes to this point here. This point here goes to that point there. So it's a graph of itself. Right? Because when you reflect it around the y-axis, you get itself. All right, so we'll finish this up on Friday. Have a good day. 0, 0, 1.